All right, guys. We're back, and this is the day 2 problem that we're looking at. I am going to warn y'all, I'm probably going to have to make 2 or 3 videos in order to fit all of this in because I have a 5-minute time limit on my videos. But on this video, we're going to talk about domain and range and maximum and minimums because they kind of go together. So I have a couple examples that are going to help y'all with number 1 and number 5 on day 2, which is domain and range and maximum and minimum. So let's start with domain and range. Okay, domain is X and range is Y. Okay. Now, essentially, we're telling where this function exists. Where does this function exist? So for domain for X, you look from left to right because this is the X-axis. So you look at the X-axis, see how the farthest left it goes, the farthest right it goes. And it's really just that. And you write it pretty much just how we said it. So the farthest left this one goes is right here at this point. And the X value there is -4. So domain, it starts at -4. So farthest left, farthest right. Now, if you look at farthest right, this arrow looks like it stops right here at 5, but this arrow means that it keeps going. So you have to kind of imagine where that arrow would go. And guys, that arrow just keeps going that way for forever. So to signify going that way forever, we have the term infinity. So on the function we have on this screen, the domain is from -4 to infinity. All right. Now range. Range is very similar. It's just the y value. So what is the smallest y to the biggest y? So we look from top or from bottom to top. So the very bottom point to the very top point. Okay, on this one, again, really not that big of a deal. So the farthest down this one goes is right here, the lowest point, since the arrows don't really affect this, which is -2. So the least is -2, and the top is right here at 2. Now, interestingly enough, range tells us the min and the max. So on that other question, we talk about minimum and maximum, okay? That's all it's talking about, the lowest point to the highest point. So the minimum is where it starts. The lowest point here is -2. The highest point here is 2. Now, those are the absolute minimum and max. On the next question, you're going to see the term relative min and max. I think that'll make a little more sense there. So example 2. All right, we're doing domain and range here, and this one probably relates a little more to the problem you'll have. So domain. You look farthest left to farthest right. All right, it's farthest left. Now, guys, it may look like it's stopping right here, but that arrow, as it's going down, is going left for forever. So the domain is -infinity to and then farthest right it goes, that arrow shows it goes forever to infinity. All right, so that is the domain, farthest left to farthest right. Okay. So the range, very similar. Range on this one, okay? You look at what the farthest down it goes is, and you might think this is part of it, and this is something, but not it. Guys, this arrow goes down for forever. So if you imagine it going down, it goes down to -infinity. And if you look at the most it goes, and this may look like it, but no, this arrow right here signifies it's going up. So range is from -infinity to infinity. Now, if you're doing max and min here, min is the lowest it goes, which is -infinity. And the max is the highest it goes, which is positive infinity. But we do have a thing called relative min and maxes, which are just places where it reaches a max or a min at a certain point in it. So a relative max, for instance, would be right here at 3. A relative min would be right here at -2. Okay, so again, the min is -infinity, max is infinity, but yeah, in general, that's how you find min and max, all right, and domain and range.